Okay, today we are going to start off with section 8.5, part 1, and we are going to talk about what happens when we multiply vectors together. So far we've talked about adding vectors, we've talked about multiplying vectors by a scalar, but we haven't talked about multiplying two vectors together. And that's what we're going to talk about today. And when that happens, when we multiply two vectors together, we get what we call a dot product. So dot product is multiplying two vectors together. So in this definition right here, we have vector A multiplied by vector B. So let's define what vector A is. Vector A would be the vector A sub 1, A sub 2, and vector B would be B sub 1, B sub 2. So you can see when we multiply these two vectors, we get the first component times the second component plus, the first component of A times the first component of B plus the second component of A times the second component of B. That should be a B sub 2. All right, so that's one way that we can write a dot product. So that is if you have your information or can get your information in component form. Now the second one we have is the magnitude of A times the magnitude of B times cosine theta, where theta is the angle between the two vectors. So let's draw a little picture here. So let's say we have vector B here, vector A over here, then theta is going to be the vector, or the angle between the two vectors. All right, so let's go ahead and look at an example of this. So this first example right here says find the dot product of 3, negative 2, and 5, 1. So to find our dot product, we're just going to take the first term in the first vector times the first term in the second vector plus the second term in the first vector times the second, it's going to be a multiplication, second term in the second vector. Multiply them together, add them up, so we're going to have 15 plus negative 2, and that is equal to 13. So I want you to notice when we do a dot product, we end up with a scalar, what we call a scalar. A scalar is just a constant, meaning it's a constant. So it gives us an actual value. It's no longer a vector. Okay, so it's not written in vector form. Okay, so for this next example, example 2, find the dot product of the two vectors shown. So in this case, they're giving us the magnitude of two vectors, and they're giving us an outside angle. So one of the ways that we can find a dot product, let's call this vector u and this vector v. So the dot product of u and v is equal to the magnitude of vector v, or u, times the magnitude of vector v, times cosine of theta, where the theta is the angle between the two vectors. So right in here is the angle we want. We know that these two angles are supplementary angles that add up to 180 degrees, so this angle inside here is going to be 150 degrees. So we need to find our dot product. So the dot product is going to be the magnitude of u, which is 7, times the magnitude of v, which is 6, times the cosine of 150 degrees. I'm going to calculate that real quick. So we're going to get negative 42. So 7 times 6 is 42. Cosine of 150 is the square root of 3, the negative square root of 3 over 2. And then our 42 and our 2's will reduce, so we'll end up with negative 21 square root of 3 is our final answer. Okay, and that's it for example 2. Actually, we can do the same one down here on our screen again. So, you gotta take a minute, pause the video, and go through and figure out this dot product right here. Okay, now hopefully you took the time to figure that out on your own. So to find our dot product of these two vectors here, we're going to do -7 times -2 plus 3 times -6. And that's going to equal 14 minus 18, which is -4. Okay, and we'll move on to the next example. Okay, so one thing that we can use this dot product for is to find the angle between two vectors. I didn't like the example that they gave us. It ended up being an answer that we didn't really have to use the full formulas for. So I changed up the numbers to be these two vectors, and we want to calculate the angle between these two vectors. So let's first of all look at the two equations that they give us. Let's go ahead and name these. So let's say this is vector u, and this is vector v. And the two formulas that they gave us were the dot product of u and v is equal to, and then this is going to be the component form, so u sub 1 times v sub 1 plus u sub 2 times v sub 2. And then the other formula they gave us was the dot product between u and v is equal to the magnitude of u times the magnitude of v. And then times cosine theta, where theta is the angle between the two vectors. All right, so this is what we want. We want theta. So to be able to solve for this theta, we need to know what the magnitude is. And then they can, we'll have that information, but we still don't have enough information just if we know the magnitude. We also need to know what the dot product is supposed to be equal to. So then we're going to have to use this equation or formula up here to find what the dot product is, then plug that in here, also find the magnitude of the two vectors, and then we can find what cosine of theta is. So we've got a couple of steps that we need to do. So step number 1, we're going to solve using the first magnitude formula. Then step number 2, we're going to find these magnitudes and plug everything back in and solve for theta. It's kind of 2 steps in one there, but yeah, we'll be good. Okay, so first thing that we need to do is find the dot product. So u dot v is equal to 2 times 4, make sure I wrote those down right, 2 times 4 plus 0 times -3. And so that whole thing is going to equal 8. Now we know that the dot product is actually equal to 8. Second step, we need to find the magnitude of vector u. So that's going to be the square root of 2 squared plus 0 squared, which is going to equal the square root of 4, which then equals 2. Okay, we also are going to need the magnitude of v, which is going to be equal to the square root of 4 squared plus -3 squared, which is equal to the square root of 16 times 9. I'm keeping track of my time here. Plus 9. So 16 plus 9 is going to equal the square root of 25, which then is 5. Okay, so now do we have everything we need? I think we've got everything we need now. So we can plug all of that information into our second formula here. So our dot product was equal to 8. Magnitude of u was equal to 2. Magnitude of v was equal to 5. And then we had cosine of theta. So we've got 8 equals 10 cosine of theta. Then divide both sides by 10. Oops. And we've got 4/5 is equal to cosine of theta. So we want to find the arc cosine of that. I'm going to pause that so I don't run out of time. I'm hoping to get all of this on one video here. Okay, so I went ahead and calculated the arc cosine of 4/5. The first solution that I get there is 36.8699 degrees. Now let's draw a picture here so we know what we're looking at. So we've got our first vector is 0, 2, so goes to there. And then the second vector goes to 4, -3, so down here. So when we are looking at this, it doesn't matter the position of these two vectors. We want to know the angle between, and so that's going to be the smaller angle between these two vectors is going to be our theta. So that's going to always be our first solution. If we went ahead and found a second solution, we would have to do 360 minus that. That would give us the outside, that bigger angle. And that is not what we want here. So when we're finding the angle between two vectors, first solution is all you have to worry about. And that's all for that example. Okay, so another thing that you will see them talk about in this section is orthogonal. So what we mean by orthogonal, if two vectors are orthogonal, that means that they are perpendicular to each other, or the angle between those two vectors is equal to 90 degrees. So theta is equal to 90 degrees. That's what orthogonal means. And I will look at an example with that. Okay, so this asks us, are the vectors -7, 3 and -2, -6 orthogonal? If not, find the angle between them. So what we need is we need to know what the theta value is. So that's, again, our two-step process. We've got to use both formulas to figure that out. So first thing we need to do is figure out what the vectors, the dot product is. So the dot product is equal to -7 times -2 plus 3 times -6. Okay, and that's going to be equal to 14 plus -18, so equal to -4. Now we also need to know what the magnitude of both of those vectors are. So the magnitude of the first vector is going to be the square root of 49 plus 9, which is equal to the square root of 58. Second one is going to be the square root of 4 plus 36, which is equal to square root of 40. Okay, and so now we can plug all that back into that second equation that we had, which tells us that the dot product, which we found to be equal to -4, the dot product is equal to the magnitude of the first one times the magnitude of the second one times cosine of 90, well, let's just call it theta because we do not know if it is actually 90 degrees or not. That's what we're trying to find out. So cosine of theta. So I'm going to go ahead and pause and calculate that. Okay, so in calculating that, I divided both sides by square root of 58 times square root of 40. And then I took the arc cosine of this value over here. And then I get theta is equal to 94.7636. So this is really close. It was very close to being orthogonal, but it was not, off by a few degrees. So our answer would be no, not orthogonal on this one. Okay, real quick on this, my open math question. We have two vectors, u and v, where u is our purple vector. It has a length of 19 and points at an angle of 20. So that's 20 degrees from the x-axis. And then v has a length of 18 and is 45 degrees from the x-axis. So when I put my vector together, I want to use that second formula, have my dot product of u and v, then the magnitude of each one, which is 19 times 18, and then the cosine of theta, where theta is the angle between the two vectors. So we would take that 45 degrees minus the 20 degrees, get 25 degrees, and then that's the angle that you will use to figure out what your dot product is.